Hello and welcome to this screencast, Romancing the Confluent Platform 2.0, Getting Started, a Developer's Perspective. My name is Jules Damji and I'm an independent software consultant working on big data technologies. I worked as a software engineer with 15 plus years of experience at various software companies in various capacities. And if you want to get in touch with me, here are my details up on the screen. Everything that I'm actually showing on this particular demo and all the sources are available at my GitHub. So at any point after the presentation, you can go down there and look at it and download and do a Git pull and give me any comments if you actually any have. Anyway, so in the next few minutes, I want to share with you my initial romance, call it my first date, if you will, with the Confluent Platform backed by Apache Kafka 0.9, which is the most recent release. In this screencast, I'll share with you a developer's perspective, that is, getting started experience through the prism of what I call the rule of three as my measuring stick. Simple steps to do simple things: installing the software, configuring if it's actually needed, launching it, how easy it is for me to launch, writing my first producer and consumer example, which is an equivalent of an hello world, and then writing a little more involved example using the Java API, and then finally what's going to be the next step or the next screencast, which is a subsequent follower of this one. And throughout with these interactions, the rule of three actually matters quite a bit in the developer experience. So what is the rule of three? Well, a friend of mine who architects software stacks for data centers procures large amount of latest and the greatest open source software stacks for his prospective clients. And given the wide array of products and platforms available today and to choose from, I asked him, how does he manage to pick the right items? What is his measuring stick? What's the secret recipe? And he said simply, Jules, it's the rule of three. That is, one, how easy it is for me to get the software. Can I just download? Can I go to the URL and download it? How simple it is for me to install it and configure it. Do I actually need a lot of configuration, or this pretty much default configurations get me actually going? And finally, and more importantly, how steep is the learning curve for me to write my first program? Your first impression on your romantic date is your comfort level, how easy it is for me to interact with the person. Similarly, no differently, from a developer's perspective, how easy it is for you to install and configure the platform. 3 easy, simple steps allows you to install and configure without having a nightmare. Or are you one of those guys who actually installs the software and at the end of it, you are holding your head in despair and not having fun? So if you are the one on the left who's actually having fun and installing rather than one on the right, essentially what the vendor has actually provided you is with less friction. And less friction is always leads to more fruition. And I am, from a developer perspective, a deep conviction of deep belief that less friction to adoption among developers always leads to more adoption and more acceptance. So then, given this particular prism of rule of three, let's see how we can actually apply it to our initial getting started experience with the Confluent Platform. So simple 3 steps. You go to the URL and you download this particular package. And once you have downloaded the package, you unzip it, obviously, and then in the conflated directory, cd to that, and then start getting on. Now, just a note of caveat that all the things that I'm doing over here apply to a single server that is in local mode. In this case, it is on my Mac. After all, as a developer, you want to get started in your local environment on a huge, rather than on a huge cluster. However, in doing so, it should be equally important that the similar experience is no different from you installing on a cluster. So whatever you do on local mode should be equivalent or not as difficult as you would be doing on a cluster. So let's see what we can do. Now, surprisingly, there are three components to this particular Confluent Platform. There is the Zookeeper used for coordination of services. And those of you who are familiar with big data technology, Zookeeper is an essential part in coordinating services, in maintaining certain configuration state, and more importantly, it is actually used to elect a particular reader in a cluster where an HA environment is needed. So Zookeeper is an essential part of the Kafka brokers over here. The second important part is the brain and the CPU of the messaging system, which is a Kafka broker or the Kafka server where all the messages are stored. And then finally, there is this notion of Schema Registry used for schema registration and metadata. The order here is quite important because for the Zookeeper must come up first for other clients to connect to it to find out who the master is and where certain configuration details might reside. So the coordination is actually quite important. Once the components are up and running, you're ready to start and publishing, subscribing using the messaging platform. So let's go down and see what does it actually take to get this thing started. It's quite simple. I'm not going to go through the process of starting the servers. These are already running. I have a Zookeeper running here. I have a registry running over here. And I have my Kafka server running on this particular 3 platform. So let's go back to our presentation and see how we can actually get started with our first CLI simple steps to do an equivalent of hello world. Now, again, rule of 3, you produce the message and you enter the message that you want to publish, and then finally you consume the message. And all these can actually be done without writing a single line of code. So what I'm doing over here is that I'm using the command line utilities. Again, I'm not writing any Java code yet. I'm writing simple command line utilities to produce a message based on a certain Avro schema. Then I'm entering the messages that I want to publish. And then finally, again, using the command line utilities, I'm going to go ahead and consume the messages that I've just published. Now, all these command line utilities reside in the bin directory, in the install directory. So once you've conflated expanded the zip file, you can actually go to the bin directory and do an ls, and you'll actually see all the directories over there. So let's go ahead and actually do the actual running of this particular program in the terminal. So what I'm going to do now is switch a little bit here and go to my terminal over here, and need one file that has all my copy and paste. What I'm going to do, the first thing is produce a message. Now this is a long command line with lots of arguments. I'm going to split it up into multiple lines for readability's sake. And the third final line is going to assign a property which actually has a schema. So this is one list of long command line argument to produce my first message. And arguments are, the topic is a test. That's where the publisher is going to publish these particular messages on the broker. And I'm providing an Avro type of schema saying that this particular record of fields will have 2 items in there. There's a key called name, which is the field F1, is of type string, and consume those message and deserialize and serialize using Avro. So we're going to hit that, and what I should see at this point is that my producer now is waiting for me to type in the messages. So in following the theme of rule of 3, I'm going to type in 3 messages over here. So let's do hello world, obviously. And given the fact that we are entering the festive season next week, why not wish everyone happy holidays. And us, being all developers, like to hack whenever we actually get time during the holidays. We do happy hacking. So those are my 3 particular messages that I'm posting or producing or publishing on a topic called test. And I'm going to hit control return. And once I've published those messages, they reside on the broker. And now I'm going to go ahead and consume those. And again, I'm going to use the command line argument to consume those messages and see what they look like. And they should actually appear in the order in which I publish. And that's very important. So in the Kafka command line utility, I'm going to take this particular command, cut and paste, and put it over here. And what I'm going to do is read all the messages from the beginning. Now, consumers actually have the ability to specify where within the particular queue or where within the topic, depending on what partition those messages are stored on, they want to start getting the messages. They want it from the beginning, they want it from the end, or somewhere in between where a record is actually kept, where you can actually find out where you want to do it. So I'm going to get it from the beginning, and voila, there we go. We have 3 messages that we just published, and we got them in the order in which we publish. So that's it, sort of very easy, simple 3 steps: produce, produce, enter the message, and then consume the message. Again, using command line utilities without writing a single line of code. Now, what if, hypothetically or realistically, that I wanted to sort of do a more elaborate, complicated message which looks like a huge JSON document. Supposing if I had a bunch of IoT devices that were publishing their state information on a regular basis, and I wanted them to follow a particular Avro record schema, this is what it actually would look like. These are all my fields that make up my device message, and that's a particular record. So that's what an Avro schema would look like. And then this is a schema I would register with the Schema Registry in order for me to publish any messages that I want on my channel called devices. And the message would look something very similar like this. You got device ID, which is normally the key, and then other fields that I can actually have depending on the readings, the IP addresses. Timestamp is quite important, because if I wanted to have some sort of a time series measurement of all the messages coming in for later analysis, I can get those messages from Kafka, put them into a time series database such as InfluxDB, and then chart them over a period of time to see any influctuations or fluctuations in my device readings. So let's see what a Java program would actually look like, which would be responsible for producing this particular schema, adhering to this particular schema, producing a particular message, and then subsequently using the command line to consume the message. So again, very simple 3 steps, but I'm going to break away just to show you some code that actually does exactly the same thing. So what I have over here is a simple Java code, which I call a simple publisher. I have a class that actually uses the Kafka 0.9 producer API to publish some stuff. Now, I have a couple of methods over here, private methods or public methods that are helper methods for me to generate device information, along with another method called build Avro schema, which is going to be something that I'm going to publish in the schema directory, so then my subsequent producers can use this particular schema to publish more messages if they want. So those are the 2 sort of important methods. And then in the main program, it's quite simple again. Create a message, create a schema, verify the schema, get the handle to the Kafka producer, and publish it. Simple 3 or 4 steps in order for me to actually write this particular program. So here in the main program, I define some properties that I assign that I want the producer to adhere to. And here I'm providing the key serializer as the Kafka Avro serializer and deserializer. Now remember, these are classes which come out of the box. You don't have to write them. You just have to specify, and the jars, and then the producer will pick up the jars as needed. And then the schema URL, which in this case is my local host. I create a particular schema. I parse the schema to ensure that it's congruent and I don't have any syntax error. And then once I'm done that, I have this particular little loop that tells me, produce 5 messages, and then produce a record which adheres to that particular schema, and then publish the data on a particular topic. And this is where I actually send the data here in the producer send. So that's a Java program. Quite simple, less than 150 lines of code that allow you to actually publish all kinds of devices that you actually want on the channel called devices. So let's see what it looks like in real time. So I'm going to go back here, and again, simple rule of 3, simple steps to do a simple producer. I'm going to create an Maven package, and do the make clean. I'll go ahead and execute that particular package that I've just built, and then I'm going to use the command line to consume the particular messages. So let's break away and go back to the terminal here. I am actually so now I'm in my GitHub repository where I have the publisher. I'm going to go ahead and use Maven Package clean to build all the Java classes that I actually need, and that's going to build the particular package and create a jar file in my target directory, and then based on the pom.xml, I have some execution plugins that I actually use to execute. So what we're doing over here is we're actually using our simple publisher class, providing it as command line arguments, 3 arguments. One is the topic name, the number of messages that we want to produce, and the URL where the schema registry resides. Now, instead of producing 5 messages, let's be a little more adventurous here. Let's do 20, okay? So let's go. So this particular Java program now, as you can actually see, has created 20 different messages of different type for different devices with different readings, and then published it on the producer using the class. And now it's actually sitting on the queue in the broker by the name of devices. Now let's go ahead and consume this particular messages that we just actually created. And we're going to use now the command line utility. I could have actually written a Java consumer, but I'm going to use that for a more elaborate program in the following screencast. But for here now, I've published certain messages. I want to see what they look like. Did they actually appear in the order in which I published? Did I miss anything? And that's a good way to sort of do some quick testing from a developer's perspective. So let's go ahead and use the same command over here to publish or to subscribe the messages that I just published. So here we go. And there we go. We've got all the messages here. Let's see. Yep, I got my 20 messages which I just published. And as you can see, they are all in the order in which we actually published, 0 to 19 messages. So that's a very simple example of what we have actually shown so far. So what you have seen essentially so far is that the number of things from the rule of 3 prism that you can actually apply to the developer experience. We saw how easy it was to download and install the Confluent platform. We saw how quickly you can use the command line utility straight out of the box without writing a single line of code to do your hello world equivalent as your first publish and subscribe example. And then finally, you could actually go a little more closer and write a Java program using the Kafka API and using the platform to do your first simple step program to produce something. So that's essential so far that you can actually do this applying the rule of 3 prism. Now, where do we go from here? What's the next thing I think I would like to do or would like to show? The next thing I'd like to do is sort of take that one step further and then create sort of a more complicated pipeline in which the Confluent platform is a messaging platform, and then I have all these publishers which could be a number of threads running on different devices producing different device information, and then publishing all of them on periodic basis to the platform with the device channel. And then on the right hand side I could actually have a Spark application which is subscribing to this particular devices and either alternatively processing in real time to alert certain things if the humidity goes up, if the temperatures goes beyond a certain threshold, or if both the humidity and temperature are something that we actually want to worry about, we can actually notify the NOC for that, and then alternatively write it to an InfluxDB time series database for further analysis, and the messages would actually look something very similar like that. So that's what my next thing is going to be. And as we approach the end of 2015, you will hear lots of predictions, you will hear lots of proclamations of trends that will be disrupting in the coming year. One thing actually is quite certain, that we are actually seeing an emergence of what I like to call the zeitgeist of distributed computing. And Jay Krabs, one of the co-founders of Confluent, actually succinctly captured the essence of the zeitgeist. He said in his tweet, distributed computing is a new normal. This is what we're going to be seeing a lot, so get used to it. And I would add one more sort of a point to this particular zeitgeist tweet, is that the platforms that will support developers with SDKs to write these distributed applications easily, needless to say, will dominate the distributive trends in the new year. And finally, thank you for listening to my screencast.